Ask My Instructor 4.2.73. Economists use demand functions to describe how much of a commodity can be sold at varying prices. For example, the demand function 500 minus 10p says that at a price of p equals 10, a quantity of 400 of the commodity can be sold. The elasticity of the demand function gives the approximate percent change in the demand for every 1% change in the price. Compute the elasticity of the demand function 480 minus 20p. We start by finding the derivative of the demand function. We use the demand function and its derivative to find elasticity. Instead of d, I put in 480 minus 20p. Instead of the derivative, I put in negative 20. After I do that, it looks like I can clean up the elasticity function by dividing the top and the bottom by 20. I can also, if I want to, multiply the top and the bottom by negative 1. It's not necessary, but it will make it a little bit cleaner. If the price is $7 and then increases by 4%, what is the approximate percent change in the demand? To answer that, we use the elasticity function. The elasticity function tells us that at a particular price, if you were to change the price, then for every 1% change in the price, the elasticity function will give the approximate percent change in the demand. For a price of $7, the elasticity is negative 7 over 17. Since the elasticity is negative 7 over 17, what that means is that the price of $7, there will be approximately 7 over 17 of a percent decrease in demand for every 1% change in the price. So starting at $7, what if you were to increase the price not by 1% but by 4%? In that case, what you would do is you would multiply negative 7 over 17, you would multiply that by 4, and you would get about negative 1.6. So increasing the price by 4% will result in about negative 1.6% change in demand. Now here we're going to generalize. We still have a linear demand function, but instead of 480 and 10, I'm putting in A and B. Now A and B are both positive numbers. What we are asked to do is to show that for this linear demand function, this general linear demand function, we need to show that the elasticity is a decreasing function. A function is decreasing if and only if its derivative is negative. So that's what we're going to do, is look at the derivative of the elasticity function. So we start off by finding the derivative of, we start off by finding the elasticity function. And to find the elasticity function, as you know, we follow a particular definition. So what's the derivative of the demand function? after you find the derivative of the demand function, you use demand and its derivative to find elasticity. I could, if I wanted to, do that same trick of multiplying the top and the bottom by -1. I'm not going to bother in this case. So what we have here is the elasticity function for the linear demand function A minus BP, where A and B are both positive numbers and P is the price. What we want to do next is find the derivative of the elasticity function. I set up the quotient rule. Notice that I don't make the negative part of my derivative. I put the negative on the outside of the derivative. That's a very legal thing to do. I just need to make sure I keep track of that negative and I don't lose it. So I need to make sure it stays out front like I have it. So I've set up the quotient rule, and next I'm going to take the derivative and of the pieces BP and BP minus A. What you want to do is keep in mind that B and A are both numbers, while the price P is our variable. So I'm taking the derivative with respect to P, the price. Next, I'm going to distribute the B, that's a number, distribute the B and combine like terms. So I distributed that real number, positive number B, and then I combine like terms. And that is the derivative of the elasticity function. Alright, so as I've been saying, and I keep saying it because it's so hard to remember, A and B are both numbers, and they're positive numbers. And they're both positive numbers, which means their product is positive. So that AB in the numerator is positive. What about the denominator? Well, the denominator is just a square. Squares are always positive with real numbers. So I have positive over positive, but with a negative out front. So the derivative of the elasticity function is negative. Therefore, the elasticity of the demand function decreases as the price P increases. We're going to look at a different demand function, and we're going to find its elasticity. Again, what we need to do is use the definition of elasticity at price P. So I need to find the derivative of my new demand function. And I rewrote it, my new demand function, as A times the price P to the negative B power. Now keep in mind, B is a number. You might want to think, oh, let's say it's 5. So this is A times the price to the negative 5 power, because B is just a positive number. Then take its derivative and clean it up, and then rewrite it in the so that it doesn't have a negative exponent. If this page is hard for you, instead of A and B, just put in, say, 7 and 5, and you'll see how it works. So the elasticity at price P is given by this somewhat ugly complex fraction, and it needs to be cleaned up. So I'm going to start on the next page cleaning it up. I have a quotient times a quotient, and if you recall, how you multiply two quotients is you go numerator times numerator, denominator times denominator. So I have AB times the price, and then I have P to the B plus 1 times A over P to the B. And then in the denominator I have two quotients, and I do that multiplication as well. Now, P to the B plus 1 over P to the B, that's just P. And then look at all the cancellations that occur. And so the elasticity function is negative B. Now, B is just a number. It doesn't depend on the price at all. And so as we were instructed to do, we showed that the elasticity is a constant function. Take care and have a great day.